Okay, welcome back, Alg 3 Trig. We are in section 3.2 today, but we already started some of it in a previous lesson. Scroll down a little bit to an example 4, where we're going to solve the equation using the quadratic formula, which you learned in Algebra 2. Now, we're going to learn two things today, the quadratic formula and this method called completing the square. I have very little in terms of examples today, so I have provided, or I will provide, additional videos if you need to watch them. Again, I don't have many examples because this was covered in Algebra 2. So it may come back to some of you, hopefully. So the quadratic formula helps us to solve for x. We can get up to 2 answers. In some cases, we can actually get imaginary solutions as well as real answers. Now, the thing about the quadratic formula is we need to get this guy equal to 0. So in my first example here, I need to subtract 7 to move it to the left. So now that it's set equal to 0, I can go ahead and label what a, b, and c are. A is always in front of the x squared term. B is always in front of the x term. And c is always the constant, meaning it does not have a variable attached to it. So now I'm going to take these three numbers and substitute them into the formula to try to get some answers. So negative b in the formula means opposite of b. So if b is 2, put a negative 2. Then a plus minus. Remember, the plus minus represents that you can have up to 2 answers. And then we have a gigantic square root. Within the square root, we have b squared. So 2 squared. Now be very careful with that b squared. A lot of mistakes people make is when the b is a negative, they accidentally do not use parentheses like they should, and it will screw up the entire problem. Then we have minus 4ac. That means minus 4 times a times c. And it's a fraction after all. In the denominator, it shows 2a. That means 2 times a. So 2 times 3. Now what to do from here? A lot of people get stuck. It's easier than it looks. What you're going to do is multiply 3 times. I'll highlight those 3 times for you. Here's 1. Here's 2, and here's 3. So let's go multiply those now. So in the radical, 2 squared is 4. There's your first multiplication. Then your second multiplication is negative 4 times 3 times negative 7. Be careful here. We have 2 negatives, so we will end up having a plus. Then 4 times 3 is 12. Then 12 times 7, 84. And finally, the third time in the denominator, 2 times 3 will get you 6. Now after that, we're still working in the radical. We need to get this radical down to one number. So we're going to add or subtract whatever it would show within the radical. Here it's showing add. So we're going to add 4 plus 84 to get 88. Now, a lot of people stop here, but when we're dealing with a radical, we need to see if we can simplify the radical. So let's try to do that now. Let's see if we can get our 2 of a kinds. So 88 can break down as 8 times 11. 8 can break down as 2 times 4. And 4 can break down as 2 times 2. So we do have a 2 of a kind of 2's that can come outside of the radical. This 2 and this 11, this 2 and this 11 must be put back in the radical and remultiplied to get 22. Now after that, we have a point where a lot of people stop. But this is a fraction after all, and with all fractions, we do always want to see if we can reduce them. So we can split this up into two fractions, and then we can simplify each fraction individually. Negative 2/6 each divides by 2 to get negative 1/3. And then again here we have 2/6 that also reduces to 1/3. And just a heads up, the one in front of the radical you would not put there, just putting it for show for the lesson. I'm going to get rid of it now. Now since both of these fractions have the same denominator 3, let's put them back and make our answer as one whole fraction. And there it is. I do have two answers here. I'm going to keep them in simplest radical form. Remember, I do not want decimal forms. So my two answers are 1 plus square root of 22 divided by 3 and negative 1 minus square root of 22 divided by 3. Again, I'm only going to hit one example in this video. I will post on Google Classroom some additional videos that you can watch off YouTube. Okay, next up, not my favorite, but we're going to learn another way of solving a quadratic, and we're going to learn a method called completing the square. That can be used every single time. Now, by the way, I do have a side note here. The quadratic formula and the completing the square, you might be wondering, why do we have to learn these? Well, we learned factoring before. But the thing about factoring is not everything can be factored or factored easily. So that's why we have these other methods of quadratic formula and completing the square. They especially deal with they help out with imaginary solutions and things that are a bit on the rougher side. All right, so example 5 says find the zeros of the functions by completing the square. So that's the method we're using. So here's the steps that we're going to go through today. Now, don't worry about the fact that these problems say f of x equals. Let's change those into zeros. Now, I'm going to turn this guy around. I usually like my x squared term on the left. So now, number 1, it says isolate terms with variables. That means that the x's will stay on the left. This guy is going to move over to the right. Now, when we did the completing the square, whenever we do completing the square, we do not want it set equal to 0. Setting equal to 0, we only want when it's factoring and quadratic formula. Now, step number 2 does not apply here. It says divide by a if it is not 1. But a is an invisible 1 here, so step 2 does not apply. Step 2 would take effect on more difficult problems, which you won't see on A and B here. Okay, step 3, add b divided by 2 squared to both sides of the equation. Well, b is negative 6, so we're going to do a little formula on the side. We're going to take that b negative 6 divided by 2 and then square it. And we're going to add that to both sides. So negative 6 divided by 2 is negative 3, and negative 3 squared is 9. That 9, we are going to add that to both sides. Plus 9 and plus 9. Now, on the right side of the equal sign, we are going to physically add it to get 19. However, what do I do with that left side? Well, that's step number 4, factor. This guy can easily be factored into, if you can think about two numbers that multiply to get 9 and add up to get negative 6. Those two numbers are negative 3 and negative 3. So you're going to do parentheses squared, And then inside, you're going to put x minus 3. I'm going to teach you a little shortcut here. Take a look at this right here. That's actually this right here. So you can take a little shortcut if what I've been doing is a little bit confusing. You don't have to overthink things. Now, step number 5, solve using the square root method, which we learned the other day. When we have parentheses squared, we want to get rid of the exponent of 2, so it'll allow us to also get rid of the parentheses. So we square root both sides. And remember, we do have to put in a plus minus to represent 2 answers. Now the square root of 19, I know that cannot be factored. It is a prime number, 1 and 19, so that square root of 19's got to stay stuck. On the left side, however, we can drop down the x minus 3 because the parentheses in the squared we were able to get rid of. Now, we are continuing to solve and get x by itself, and that's one easy step to finish this problem. Get x by itself, we would add 3. Now, please do not add 3 to the square root of 19. They are not like terms. So you need to keep them separate, and it is rather ugly, but here's the answer, or answers. So my answers are 3 plus square root of 19, and 3 minus the square root of 19. Okay, let's try another one. So first thing I want to do is change the f of x into 0. We don't need that fancy notation. Then let's make things look more appealing how we're used to. Just reverse things. Now, what do I do from here? Remember, step 1 the first step is to isolate the terms with the variables, meaning don't want it equal to 0. So let's add 12 to both sides. What do I do from there? Step 2, divide by a if it is not 1. If that doesn't apply here, a is an invisible 1. Step 2 is not needed. Now I go to step 3. Let's add b divided by 2 squared to both sides. What's the b here? The b is in front of the x. 4. So 4 divided by 2, then I'm going to square it. 4 divided by 2 is 2. And then 2 squared is 4. So I'm physically going to add 4 to both sides. Since I left myself some space, let's put it right here and right here. So on the left side, just bring down your x squared plus 4x plus 4. And on your right side, 12 plus 4 makes 16. Then after that, we want to factor the left side. So we're going to put parentheses squared, just like the last problem. And then remember the shortcut is x plus 2. Where did I get the shortcut? Right here. This 2 is a positive, so that means plus 2 can go in your parentheses. Bring down your 16, and now you're ready to do step 5, solve using the square root method. So we have parentheses squared, just like last problem. Let's get rid of the parentheses squared by taking the square root of both sides. So it'll cancel and just bring down a nice easy x plus 2. And then on the right, you need a plus minus. Now this guy, square root of 16 is 4. We actually have a problem that no longer has a radical. So let's see what happens here. Well, we got to continue to get x by itself, so we would subtract 2. Now these guys are like terms, so that means I will add and subtract. I'm not going to leave it ugly like my previous problem because I no longer have a radical. So to get my 2 answers, I do negative 2 plus 4, which is 2, and negative 2 minus 4, which is negative 6. So there's my 2 distinct answers. Okay guys, as I've said before, I will post additional videos for you to watch on quadratic formula and completing the square. If we scroll down, what did I prepare you guys to do? If you scroll down to assignment 3.2, I have now taught you how to do 27 to 32 for completing the square, 35 to 49 for the quadratic formula, and then on the next page where it says find the zeros algebraically for 69 to 73, you can just use your own method. You can factor, or you can use the quadratic formula, or you can do completing the square. All right, that's the end of my lesson.